Okay, welcome back, guys. So we're going to head into homework 23, area and estimating with finite sums. Now, it says listen to video for full guided solutions. That's because over here I have a lot of hints, but I want you to see me do it in real time if you need that extra push. So we're given a function. The font is very small here, so I'll rewrite it. We're given a function f of x equals 5x squared. In the first command, we're told to find a lower sum with two rectangles of equal width, and we're looking over the interval of 0 to 12. I'm just going to write that here, over the interval 0 to 12. So I've set up the drawing on the next page. So we're looking over the interval from 0 to 12. You always want to start with a sketch of your function, and it said lower sum. In this situation, that's a left endpoint method. Why? Because the left endpoint of the rectangles is what's going to be touching the curve. So you're dealing, basically I'm going to write this here. So a sub 1 basically has 0 area. Rectangle 1 has 0 area. Rectangle 2, here, I'm going to call a sub 2, has a certain area. But let me change the color here. What's the distance from here to here? Clearly 6 units. But what's the distance from here to here? Well, that depends on the function evaluated at 6, which is 180. And that's why I like to put in these ordered pairs, 0, 0, 6, 180, and 12, 720. So I like to put the ordered pairs with regard to, these where the x-axis is partitioned. So anyhow, the area of this rectangle ends up being 6 times 180. So we crunch that out then, a sub 1 plus a sub 2, 0 area plus 180 times 6, and 180 times 6 is going to lead us to 1080, 1080. So now if you look back, you see the answer to part A is 1080 square units. So you can see all this fancy notation here, but you don't really need it. Clearly you can just draw the rectangles and do it using good old-fashioned geometry. Let's try again. A lower sum with 4 rectangles of equal width. I'll hit pause as we draw that. Well, one thing you have to think about doing is partitioning the x-axis in 4 equal parts if you want 4 rectangles. So 12 minus 0 divided by 4 is equal to 3. That means from your start point to here, this is 3 units, okay, then plus another 3 units. It's going to bring you to 6, plus another 3 units is going to bring you to 9. So 3, 6, 9, 12. We've partitioned the x-axis. Now let's draw in our rectangles. So the first rectangle really has 0 area. I'll put a point here, and the next rectangle, using that left endpoint method where the left endpoint of the rectangle is touching the curve. And voila. So if you're using that left endpoint method, clearly it's going to be an under approximation. Note to self, clearly this is going to give us an under approximation of what the true area is. So let's just kind of sketch this out. Area of rectangle 1 is 0, doesn't have any area. Area of rectangle 2, which is this one right here, well, the distance from 3 to 6 is 3 units, but the height of that rectangle depends on the function evaluated at 3. And I'm just going to write that here. Area of rectangle 3, its base is 3 units, but the height of this rectangle depends on the function evaluated at 6. And then the last rectangle, area 4, the base is 3, but it depends on this rectangle here. Its height is dependent upon f of 9. Alright, so I'm going to hit pause as we crank that out. So I can just remind you, f of 3, the original function, was 5x squared. So 3 squared is 9, 9 times 5 is 45. So with this, we can even map this out here. With this, we're looking at whatever 3 times 45 is. With this, we're looking at whatever 3 times, well, let's see, 6 squared is 36. And 36 times 5 is 180. And this last one, f of 9, well, 9 squared is 81. And 81 times 5 is 405. So like I said, we're going to have to take this value and this value and this value and add it all up. And then, of course, plus 0. Okay, and voila, if we add this number, this number, this number, and this number, we will arrive at the total area being 1890. Now let's go ahead and look back at our original cheat sheet here for part B. Indeed, the answer is 1890. I just wanted to see, let you see that happen in real time. And then the last part is estimate the area using an upper sum with 2 rectangles. And the drawing is here, but with this I really wanted to show you what Wolfram Alpha has. We've been using that a lot this term. It has a really good capability of handling these rectangles and drawings for you. So I'll hit pause as I pull that up. Now, as you can see here, I went to Wolfram Alpha on, it's funny, I'm taking a live video of another iPad, but I typed in left endpoint approximate of 5x squared from 0 to 12, and it drew it, and it gave me the answer, but notice how it says using 5 intervals. So now, that homework problem said to do it with 2 intervals, and it said right endpoint method. So I just want to play with, what can you command it? So I went back up, you can see it now. I wrote left endpoint approximate using 2 intervals. And I'll even circle where I wrote that, right here, using 2 intervals. Okay? And now what's really neat is I paged down, I'll let you see here. So originally it drew the left end approximate, and it gave me the exact answer. Okay? Now I'm going to page down, and what's really cool is it gives you this table. So especially, if you have the app on your iPad, and it gives you this table, so it's giving you the left end approximate, which we had done earlier, and the right endpoint approximate. So check that out, the 5400. So now, if I go back and check the answer key, you see, the answer for the upper sum with 2 rectangles was 5400. So, long story short, what I'm getting at is Wolfram Alpha can be very good at helping you find these values if you don't have time to crunch them out by hand. Okay? We have one more homework problem. Okay, and I start by reading this to you. It says, using rectangles whose height is given by a value of the function at the midpoint. Aha! So this time we're going to be using midpoint approximation, or midpoint rule, of the rectangle's base. Estimate the area under the graph using first 2 and then eventually 4 rectangles. So we're starting with, it's probably really small for you to see unless you've printed out the homework already, but it's f of x equals x cubed. You can see I have a lovely sketch over here. I always start with a sketch. The area of the region with a curved boundary can be approximated by summing the areas of a collection of rectangles. Using more rectangles can increase the accuracy of the approximation. So we're going to look over the interval from 0 to 2. You can see here that we have 2 partitions of equal width. So now it may appear as though that first area is 0, but it's probably not quite 0. So remember, you're using midpoint rule. So now the midpoint, the height of the rectangle depends on the midpoint of that interval. Well, that means we're really interested, what's halfway between 0 and 1? 0.5. So we're really interested in f of 0.5. And what's halfway in between 1 and 2? 1.5. We're really interested in f of 1.5 as well. So let's go ahead and set that up. So the area of rectangle 1, well, the distance from here to here is clearly 1 unit. But the height of that rectangle is f of 0.5. And rectangle 2, that's this rectangle right here, it's, the distance from 1 to 2 is clearly 1 unit. but the height is dependent upon the function at 1.5. So once again, we're going to crank this out, do some number crunching. I'll hit pause. Okay, so you can see here f of 0.5, so whatever 0.5 cubed is, which is 0.125. So that's 0.125, which is, you see here, 1/8. And f of 1.5, so what's 1.5 raised to the third power? Is a 3.375. So that's what I was figuring on over here. Okay? So you want to figure on those. Then you can get the areas of those two rectangles. So 0.125 plus 3.375 is 7/2, which will come to be 3.5. All right? So once again, you know, we use midpoint rule. I'd like to play with Wolfram Alpha and see, let's up the ante from 2 rectangles to 4 rectangles, and let's use Wolfram Alpha. I'll hit pause. So I did want to show you, I have the live cam on now. I typed in midpoint approximate of y equals x cubed from 0 to 2 using 2 intervals, and look at that. I'll circle it. Gave us the result, 3.5, which we had found earlier. I remind you right here, 3.5. And it even gives us a nice little sketch, you know, which we had sketched ourselves earlier. All right. Now what I'm going to do, though, is I'm going to change this from 2 intervals to 4 intervals. I'll hit pause. And voila, you can see I changed it, used 4 intervals, still midpoint approximate, and gave us our result, gave us a nice little picture. And if I page down, I remind you that we always have that nice little table that gives us, I like to call it the comparison, really, between what the left endpoint method, which would be an under approximation, the right endpoint method, which would be an over approximation, the midpoint rule, which comes even closer to the true value, and then you get into Simpson's rule, which we haven't talked about yet, but we come closer to the exact value of the area under the curve. So, all right, hope that helps. That was a short homework. Good luck out there.